Hello everyone and welcome to the fourth video of the grade 10 second term series. I'm Sanjay Boshmans, and in the previous video we discussed about the second conversion method, that is the place value method. Now that we have completed two conversion methods, in this video I'm going to explain to you the third and the fourth method, that is the 3-digit and the 4-digit method, in which we will be converting binary numbers into octal and octal numbers into binary, again binary into hexadecimal and hexadecimal into binary. And we will also discuss how we can convert between octal numbers and hexadecimal numbers. Okay, let's get on with the video. The first method that we are going to discuss today will be binary to octal. Before going into the calculations, we need to know that any octal number is composed of three binary numbers. So one octal number will be composed of three binary numbers. So to convert any octal number to a binary number, we need to use the 3-digit method. So we will see how the 3-digit method works. We will convert first a binary to octal, and then we will see how we can convert an octal number back to binary. For this, I am going to use a table. In this table, I am going to have three columns. If you can remember the first three place values for the binary numbers, we know that 2 to the power 0 is 1, 2 to the power 1 is 2, and 2 to the power 2 will give me 4. So I'm going to use these three to create a binary to octal conversion. Now we know that an octal number system has 8 digits, 0 to 7. So starting from 0, let's see how the binary numbers for the corresponding values for the octal numbers is formed. Let's look at 0. If you can see in the table, I have mentioned that I'm not going to add any of these numbers to create 0. So 0 is none of these values. So the value of octal 0 would be binary 3 zeros. Now let's look at the second one. We have 1 there. In these numbers, if you look at the headings, if I add 1, I will not need the other two values to create the value 1. So I would write a 0 to those two values. So to create the value 1 in octal, I just need to put a 1 for the value 1 in the table. So the value for the binary value for the octal number 1 would be 001. If I want to get the value 2 in the table, I will have to write 1 for under 2. So the other two values will give me 0. So the value for octal 2 is 010. Next, I have 3. So I don't have 3 in my table. To get 3, I need to add the values 2 and 1. So I will be writing 1s in both the columns 2 and 1, which will give me 3. And the column 4 will be 0. So the value for octal 3 would be 011. Octal 4, I can straight away say there is 1 for 4 and the rest 2 will be 0. And octal 5, I need to add 4 and 1. So the value for 2 would be 0. Then to create 6, I need to add 4 and 2. Then for 1 I will have a 0. So 6 would be 110. And the last one, 7, will be the addition of 4 plus 2 plus 1. which will give me 111. And these will be the corresponding binary values for each of the octal digits that we have. Alright, so let's do a small conversion and see. Let's first convert a binary number into octal. Let's look at this particular binary number. 10010111101. Now to convert a binary number into octal, the first thing that we have to do is to divide these numbers from the right side into groups of 3 digits. So from the right, if I start, I'm going to divide 3 numbers, then another 3, another 3, and I'm left with 2 digits there, which I can fill it up with an additional 0. Now what we have to do is we need to write the corresponding octal values for these 3-digit values. So starting from the first one, I have 5 here, then this is 7, this is 2, and this is 2 again. So if I put them together, this will give me the octal value for the binary number that we have had in the beginning. So this is how you convert a binary number to octal. Now let's look at the other way around, how we can convert an octal number to binary. Let's look at this octal number, 2573 base 8. Each of these octal number has a 3-digit binary value. So I'm going to write them down in order. 2 would be 010, 5 101, 7 would be 111, 3 would be 011. If I put them together, it will give me the corresponding binary value for the octal number that we have. So this is how you convert binary to octal and octal to binary using the 3-digit method. Now let's look how we can convert a binary to hexadecimal and then back to binary. For this, I'm going to use a larger table like this, which will have 16 values for all the hexadecimal values. The headings for this would be 1, 2, 4, and this time 2 to the power 3, that is 8. Now I am going to have 16 different values. Let's start with 0. 0, of course, we know there's nothing to add, so all 4 will be 0, and the corresponding 4-digit value for hexadecimal 0 is 4 binary zeros. To create 1, I just need to put 1 here and all the rest will be 0. So hexadecimal 1 is denoted by the binary value 0001. To create 2, I just need to put a 1 under 2. So the value for 2 would be this. 3 is 2 plus 1, so 1, 1 for 2 and 1 columns will be there, which will be denoted as 0011. Then 4 is just like the octal number, 4 there, and the rest will be 0. Fifth one, that is 0101, 4 plus 1 is 5. Then for 6, 4 plus 2, that would be that. So to get all these values, we need to add them up, add these numbers up, and to get all the rest of the values, we can add these numbers. Now you can see for 7, I have all 3 zeros here, 4 plus 2 plus 1. For 8, 8 will be 1, the rest will be 0. 9 is 8 plus 1, and so on and so forth. I can fill the whole table and get the corresponding binary values for all these hexadecimal values. Now the conversion is very similar to what we did with octal numbers. Now let's try to convert a binary number to hexadecimal. Let's say we have a binary number like this. We know in the earlier method we divided this binary number from the right into groups of 3. But this time, because it's hexadecimal, I am going to divide them into groups of 4. And the fourth one, the last group has only 3, I am going to add a 0 there. Now I am going to write the corresponding hexadecimal values. D, B, and this is 4. When I write them up together, it will be 4BD to the base 16. So the hexadecimal value for the given binary number would be 4BD base 16. Let's convert a hexadecimal number to binary. Let's say I have 8B7F base 16. Each of these value is going to have a 4-digit binary value. For 8, it would be 1000. For B, it would be 1011, which is 11. 7 would be 0111. And F, which is 15, would be all ones. When I write them together, it will give me the corresponding binary value for the above hexadecimal number. So this is how you convert a hexadecimal number into binary. So now we know the 3-digit and the 4-digit method to convert binary into octal into binary, or binary into hexadecimal to binary. So these will be the two methods. Now let's say we need to convert an octal number to hexadecimal, or a hexadecimal number to octal number. There is not much of a difference in the conversion, because we are going to use a mix-up of the 3-digit and the 4-digit method to do this work. Now let's look at this octal number 4721. In the beginning, because it's an octal number, I am going to write the binary number for this. So we know one octal number consists of 3 binary digits. So I am going to write the binary numbers for octal 4, that is 100. Octal 7 is 111. Octal 2 would be 010. Octal 1 would be 001. Now that we have this binary number for the octal value, I am going to divide this binary number into 4 groups, because I need to convert this into hexadecimal. So starting from the right, I am going to divide these 4 numbers, and the rest I have 4, so I am not going to divide anymore. Now I just have to write down the corresponding hexadecimal values. It is 9 for the first one, second one would be D, third one would be 1, and base 16. So this is how you convert an octal number into hexadecimal. Now let's see the other way around, a hexadecimal to octal. I have this hexadecimal number, that is 4DP8. We know 4 is 0100. Now look at this, we are going to write 4 digits for each binary, that is hexadecimal to binary. We know it is a 4-digit number. So each of these digits will have 4 binaries. Then D would be 1101, B would be 1011, 8 would be 1000. Since we are going to convert this into octal, I am going to divide them from the right into groups of 3. First group, second, third, fourth, and the last group, and I am left with 0, for which I can add 2 more zeros. But still it is going to give me the value 0, so I will not add them up in my final answer. Starting from the first one, 100, I'm going to write the corresponding octal value. 100 would be 4, 110 would be 6, again 110 would be another 6, 111 would give me 7, and the last digit will be zeros. 0 on the right side need to be included in your answer. 0 on the left should not be included. So this 0 will be there. So the corresponding octal number for the above hexadecimal number would be 46670. So these will be the 3-digit and the 4-digit method conversions. We can convert a binary to octal and back to binary, a binary to hexadecimal and back to hexadecimal using the 4-digit method. And using the 3-digit and the 4-digit method, I can convert between hexadecimal and octal numbers. So these will be the different conversion methods among different number systems. The 4 methods that we saw was divide by the base, place value method, 3-digit method, and the 4-digit method. Now with these 4 methods you can do all the conversions that is necessary for your examinations. Now that we know all 4 methods, I want you all to try out all the conversions in your past papers and see if you all are able to do it without any problems. If you can do all of them, if you know all 4 of these conversion methods, you can do all of those conversions in your past papers. So in the next video we will be discussing a new topic about memory and memory devices. So until I see you all in the next video, this is Sanjay sir signing off. Take care and God bless you.